Very good afternoon, students. Today we have to see the next part of our fifth unit, that is cement, properties of cement. Okay. So which are the properties of cement, students? There are three main and important properties of cement, that is, first one is setting and hardening. Second one is soundness of cement, and third one is heat of hydration. So we have to see all these one by one. Let's start with setting and hardening. Whenever a cement mix with a water, it forms a plastic mass which is called as cement plast, and these cement plast after some time become hard, and this is called as initial set. That hardness of cement is only because of the type of reaction takes place in that. Which type of reaction takes place when water mix with cement? Hydrolysis and hydration. These are the two reactions which takes place when water mix with the cement. Okay. Now, what is exactly the definition of setting? See, setting, a stiffening of original plastic mass due to the gel formation are called as setting. Okay. And what is hardening? A development of strength due to crystallization are called as hardening. Okay. So whenever we mix water in cement, it forms a plastic mass, and that plastic mass after some time become hard. Okay. So that hardness is because of a crystal formation, and the strength which cement get, that because of the gel formation. Now, setting and hardening is nothing but the physical and chemical change takes place in the cement. See, first cement is in the powdered form. Okay. Then we mix water in that. It first form a gel, and some part of that cement responsible for the formation of crystal, and that gel and crystal bind together very tightly and provide a strength to the cement. That is nothing but the setting and hardening. Now, which chemical change include? The chemical change which takes place in the cement include hydration and hydrolysis of a constituents of cement. Okay. Which constituents present in the cement? C2S, C3S, C3A and C4AF, that can be previously learned. C2S means dicalcium silicate, tricalcium silicate, tricalcium aluminate, tetracalcium aluminoferrate. All these are the constituents of cement, and these constituents, when react with water, undergo hydration and hydrolysis reaction, and this is nothing but the chemical change in the cement. And which type of physical change? Firstly, cement is present in the powdered form. After that, after mixing with water, it will be changed or converted into crystal and gel form. That is the physical change. Okay. Now, we have to see hydration and hydrolysis of C2A, C3A, C2S, C3S, C3A, C4AF as above. See what happen when C2S is react with water molecule. X number of water molecule, and it will form C2S X H2O. Okay, and this C2S X H2O is responsible for gel formation. Now this C3S, when react with X number of water molecule, what happen? It will form C2S X H2O, and as we see above, it is responsible for gel formation and the remaining molecule is CaOH by 2. This remaining C contain CaOH by 2. Now C3A when react with 6 number of water molecule. How many number of molecule? Water molecule, 6 number of water molecule. It will form C3A 6H2O, and this tricalcium aluminate 6H2O is responsible for crystal formation. Now the remaining is C4AF. When C4AF react with 6 number of water molecule, it will form it required 7 number of water molecules, and it will then form C3A 6H2O, which is responsible for crystal formation, and the remaining compound is one C is remaining, one F is remaining, and one H2O molecule, and this is responsible for gel formation. Now these are the hydration and hydrolysis reactions of dicalcium silicate, tricalcium silicate, tricalcium aluminate, and tetracalcium aluminoferrate. This type of reaction takes place when it react with or come in a contact with water molecule. Now next is the gypsum. As we see, what is the role of gypsum? It increases the setting time of cement. How? Gypsum is nothing but CaSO4 twice H2O. When this gypsum added in the cement, it react with C3A and water molecule and form C3ACaSO4 X plus 2 H2O, and this is responsible for gel formation. See, actually whenever C3A react with water molecule, it will form a crystal. But here as soon as we add gypsum in the cement, then this gypsum retard the crystal formation of C3A, and instead of it form a gel. And for the setting and hardening of gel, more time is responsible. As we know that, this can be seen previously that C2S, for C2S, setting of C2S, we required 28 days. Okay. Then for setting of C3S, we required 7 days. For setting of C3A, we required 1 day, and for setting of C4AF, we required 1 day. This much day is required for setting and hardening of cement. So firstly, in the first day when cement get rigid and hard, that is only and only because of C3A and C4AF, because is only required 1 day for crystallization or crystal formation. So that type of hardening or setting is called as initial set or initial setting. Okay. Now C3S required 7 days for hardening. So this is called as cement setting. And C2S, for hardness of C2S or for stiffening of C2S, we require 28 days, means final setting and hardening of cement takes place after 28 days, and this is called as final set. After 28 days, a proper setting and hardening of cement takes place. I hope that all of you understand fully what is the meaning of setting and hardening and how does it takes place and which type of reaction takes place for setting and hardening. Okay, so further one more time we see the definition of setting. What is setting? It is the stiffening of original plastic mass. It is the stiffening of original plastic mass, this mass formed by adding water in cement, due to gel formation, that is called as setting. And what is hardening? Development of strength due to crystallization are called as hardening. So these all are the most important properties of cement. Now next property can see in next video lecture.